Okay, remember tomorrow that your test will be shorter than this. It'll be somewhere between 10 and 15 questions, but all the questions would be similar to this. Kathleen rolled a number cube that has labels 1 through 6. What is the probability she gets a 2 or a 4? Remember, when you're calculating probability, the number of total possible outcomes is in the denominator, 1 through 6. And since there's 2 or a 4, there are 2 numbers that could be in the numerator. So 2 out of 6, which is the same as 1/3, which is why B is the correct answer for number 1. 10 red marbles, 15 green marbles, 15 blue marbles. There are a total of 40 marbles. We find that by adding 10 and 15 and 15 more. If Deshaun draws a marble from the bag, what's the probability that it would be a red marble? The total number of successful marbles would be 10 out of 40. And simplifying that, we would divide both of these by 10, which would be 1 out of 4, which is A for an answer. Kendra flips a coin 3 times. What is the probability she'll flip tails all 3 times? This is a compound event. And with compound events, you can create a table, or you can know that you can figure the probability of event 1, event 2, and event 3, and you can multiply those probabilities together. So, on event 1, getting aheads would be 1 out of 2. Event 2 would be 1 out of 2. And event 3 would be 1 out of 2. So, in the numerator, 1 times 1 is 1 times 1 is 1. In the denominator, 2 times 2 is 4, times 2 more is 8. So the probability of getting all 3 of them with tails is 1 out of 8. The probability that John receives junk mail is 11%. 11% as a decimal is 0.11. If he receives 94 pieces a week, about how many can he expect to receive in junk mail? So this is a prediction. With predictions, we multiply the probability times the number of times that we're going to do it. 0.11 times 94 is 10.34. So this would be approximately 10 out of the 94 pieces. Gene made a 2-digit code. The first code is odd, and the second code could be anything. So there's the numbers 0 through 9. In other words, there would be 10 possibilities. 0 through 9, there would be 10 possibilities. The only thing is on the first one it says that it had to be an odd number. So I can only use 1, 3, 5, 7, 4, 9. So there's 5 possibilities for the first one, and yet all 10 of them are possible for the second one. And when you're figuring combinations, you simply multiply the number of possible in each one, which means there's 50 combinations. Number 6, if you choose between 3 pairs of pants and 4 shirts. This is a combination problem again. So all you have to do is take the number of possible in the first event, pants, 3 pairs, and the number possible in the second one, 4 shirts, and you multiply. 3 times 4 is 12. I could put together 12 different outfits with this combination. A classroom has 7 blue chairs, 5 green chairs, 18 red chairs, and 9 yellow chairs. If the chair is selected at random, which color is most likely to be chosen? In this problem, although I could figure probability, all I have to do is look at the number of chairs. 7 compared to 5, blue is more possible than green. 18 red. 18 is certainly more possible than 7 or 5. 18 is also more possible than yellow, which only has 9. So the most likely combination is red. If you spin a spinner that has equally sized yellow, green, and blue, if I spin a spinner and it has yellow, green, and blue, it says what's the probability that they'll spin orange? Remember, there's 3 possible outcomes, yellow, green, or blue, and you look for the number of those outcomes that could be orange, which is 0. 0 divided by 3 is obviously 0. There's no chance, it's absolutely certain not to happen. The experimental probability that she'll win a game is 3 out of 8. If she plays 80 times, how many can she expect to win? This is a prediction problem. With predictions, we always multiply. So I'm going to take 3 times 80, and I'm going to divide that by 8. 3 times 80 is 240. 240 divided by 8 is 30. So I can predict that she'll get that 30 times. Jackson flipped a coin 10 times. He flipped heads 4 times and tails 6 times. What is the experimental probability? That's an important phrase, experimental probability. He did an experiment. He did it 10 times, so the total is 10. Jackson will flip heads. He flipped heads 4 times. This is the same as 2 out of 5. So the experimental probability that he'd get heads the next flip would be 2 out of 5. If I was talking about the theoretical probability, theoretical means equal chances, the theoretical probability would be 1 out of 2. So make sure that if you're doing something that says experimental, that you're using the data from the experiment to do your calculations of the probability. Melissa rolls 2 number cubes, each labeled 1 through 6. This again is a compound event. You could create a table, or you can look at the probability of getting a 1 on the first cube, 1 of them out of 6. On the second cube would be 1 out of 6. And with a compound event, we multiply our 2 probabilities together. So I'd have a total of 1 out of 36. A sandwich shop offers 3 types of bread and 4 types of meat. Again, this is a compound event. If there's 3 types of bread and there are 4 types of meat, there is a total of 12 different types of combinations that we can put together. The probability that Doreen wins a game is 1 in 3. This is a prediction problem. They told me the probability would be 1 in 3. They said, how many is she going to win out of 300 times? So I'm going to take 1 times 300, which is obviously 300, and I'm going to divide that by 3. So I would expect that she's going to win 100 times out of the 300. In number 14, they've given us a table, so obviously this was an experiment. It says Tyler recorded the hair color and eye color of students walking in the hallway outside her homeroom. What is the experimental probability, in other words, use the data, that the next student she sees will have blue eyes? Well, what I need to know is totals. So 9 and 12 is 21. 5 and 14 is 19. And I can add these 2 together to find out that there was a total of 40 people that went past. Even if I look at it going this way, 9 and 5 is 14. 12 and 14 is 26. If I add them up going this way, I can see that my total number of people that I was taking information on was 40. So 40 is my denominator. And they want to know how many of them have blue eyes. Notice the hair color did not matter. Blue eyes would have been this column. So the total of blue eyes was 19. So the probability that the next person would walk by would have blue eyes would be 19 out of 40. Brianna rolls a number cube that has sides labeled 1 through 6 and flips a coin. So if it's labeled 1 through 6, there's 6 possibilities. And if I'm flipping a coin, it has heads and tails. There's 2 possibilities. So when I get done, I should have 12 different things that I've listed. Well, I could roll a 1 with the heads. I could roll a 2 with the heads, a 3 with the heads, a 4 with the heads, a 5 with the heads, or a 6 with the heads. Or I could roll a 1 with a tails, 2 with a tails, 3 tails, 4 tails, 5 tails, and 6 tails. And you'll notice that when I get all done, there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible outcomes. Maria randomly selects a number from the list of numbers below. There are 1, 2, 3, 4, 5 numbers. What is the probability that she selects an even number? If I go back and look, this is even, this is even, this is even, this is even, this is even. 5 out of 5 are even numbers. 1 or 100% chance. In other words, this event is certain to happen. I can't pick anything that's not even. Number 17, I can see was experimental again, and they're talking about experimental probability down here. I know it's experimental because I see the data. Kelly conducted an experiment. In each trial, she flipped a coin and rolled a number cube. The results are shown. What is the experimental probability her next flip will be tails? So really, all I'm interested in is the tail side of this information. The number doesn't really matter. The numbers here don't make any difference. The number of trials that she did were 5. And I want to see how many of those trials actually had tails. 1, 2, 3. So the probability that her next flip will be tails would be 3 out of 5. Colleen wrote each of the letters A through Z on a separate piece of paper. Since I'm writing the letters A through Z, we need to know there's 26 letters in our alphabet. If she randomly selects a piece of paper from the hat, what is the probability that the next letter that will have an A, E, I, O, or U? 1, 2, 3, 4, 5 different possible letters to select. So there'd be 5 out of the 26 letters in the alphabet. If you planted a garden with equal number of roses, daffodils, and tulips. Roses, daffodils, tulips. There's an equal amount in each of these. What is the probability that you would get a lily? Well, there was 3 possible, and of those 3, none of them were lilies, so there's a 0% chance. In other words, it's absolutely not going to happen. Make sure you go over all the problems. Make sure you know how to work them out. Remember, tomorrow you should expect anywhere from 1 to 15 questions on the test. And also you want to make sure that you go back through and you look at your old mastery tests, because we will be doing those tomorrow as well. And just as a refresher, if you have negative plus another negative number, these have the same sign, so we'd add them together and keep the sign. They have the same sign because they are both negative. I add 2 and 3 and get 5. This would be a negative 5. If they have different signs, I look at the absolute value of each number and ask which is larger. Is 5 larger than 3? The answer is yes. So I keep the sign of the larger number, which in this case would be negative. Instead of adding them together, now I subtract the smaller number from the larger. So 5 minus 3 is 2. Now remember, the rules for addition and subtraction are different from that of multiplication and division. If I have a negative number times a negative number, it'll always be positive. In other words, a negative 2 times a negative 3 would be a positive 6. And the rule for division is the same. If I have a negative 6 divided by a negative 3, I'm going to get a positive 2, because a negative divided by a negative would make a positive result. If I have a negative times a positive, it would give me a negative result. So negative 2 times positive 6 would be a negative 12. And the same rule works for division. Make sure you go over all of your questions. Remember, tomorrow there'll be 1 through 15. And make sure you go over the concepts that were on your mastery test. By now, we should be able to add and subtract, multiply, and divide. Just a reminder that these will all be integers, which means no fractions or decimals when you get done.